What's up, good people? So আমরা আজকে হচ্ছে একটা রিসার্চ পেপার বানাবো। তো এই রিসার্চ পেপারটা হচ্ছে টেকনিক্যালি বেভারেজ অফ কোলা রিলেটেড। So how things degrade, not things actually, how your oral, I don't know specific medical terminology or what should I use technically, but we're trying to figure out how your teeth might degrade, just like my teeth have degraded for over consuming of cola. What could its impact, and what could be referring to the degradation of tooth when you consume too much Coca-Cola or beverages. I'm not to Coca-Cola will be swimming, so I will not try to announce their name. It's more like um, beverage. We will just name this. So since we are to the starting this film, so this film was sponsored by Hassan Bhai. A big shout out to him for Perplexity AI. If Hassan Bhai wasn't there for us, we would never, we would never have Perplexity AI Pro Edition. So, alright, I have a simple prompt for you guys so that you can build your own research paper through AI, and we will eventually figure out how to bypass the writing so that you guys don't get interrupted by Turnitin, although you will. You can make my words for it. Alright. So if you can see the screen, then I will copy paste the prompts I have previously given and try to deep search it. So uh, through Perplexity AI. So I will click the deep search model. No, this is not the one. This is the one. And I will I will use the wave, not other stuff. So here we go, and let's wait for Perplexity to do its magic. We will try to do some researches and simulate data and figures and structure the full paper. We are currently building this for IEEE style, not exactly Elsevier, because since we would be applying stuff based on Internet of Things sensors, like when you have a specific cola or beverages, when you open it up, it has specific temperature and pH, right? So what we can do, we can measure the pH over time that is still degrading. It may be lower or higher, and from that point, we can connect in Arduino and collect the data in CSV format. If we try to figure the concentration over time, that will give us a very comprehensive data, and we can stem this up into a time series model, which we have learned. If you guys have learned in statistics, uh, we can apply LSTM and other models rigorously so that we can find our ideas and generate some comments over this. So the search has been completed as you guys can see on the screen. So they have Perplexity AI have suggested us to Elsevier, although we wanted IEEE style. So the title they have been given us is Predictive Modeling of Acidic Vaporage Degradation using low-cost IoT sensor and ensemble machine learning. Alright. So what is ensemble machine learning? Ensemble machine learning is more like you learn from data and apply it over time to time to manage to fit the curve actually. So what they have tried to write over here from the search is like beverage industry faces significant challenges, expensive laboratory analysis, blah blah blah, and we are trying to develop a low cost IoT sensor fusion framework. Yeah, that's fusion framework since we're applying machine learning. Although we will be applying machine learning based on our server, they have tried to design an Arduino Uno and a pH probe, right, and a temperature probe to track the degradation profile of commercial cola and lemonade. And to add salt to the wound, they have asked us to have data over 60-day accelerated shelf life. Oh boy, this is gonna be a very long process because I don't have much time to release this one. And more than this, they have this ML architecture, random forest executes and LSTM, the long short-term memory. Oh boy, executes outperforms other models, achieving a coefficient of determination R square is equal to 0.96, and root mean square error is 0.08 for pH prediction. I don't know how they model this. Probably I just made some error in the prompting. So they have given us an introduction. Alright, cool. And current study objectives, fine. Materials and methods, experimental design, IT sensor data and stuff, system architecture. But they haven't given us the block diagram of the sensor system. Cool. Calibration. Sensors are calibrated weekly, which we shouldn't collect data so weekly. Although we will try to figure this out within 15 minutes. Not 15 minutes. We'll try to at least adjust the data to at least 2 or 3 days. And they have asked us to validate this against a mercury thermometer, which is NIST traceable. Oh boy, that's gonna cost us some money. And they have tried to figure this out through titrable acidity, which was taken through zero point 0.1 normality, if you can see very clearly, with the endpoint of 0.82. I don't know how they came up with this result. Did someone make this before? I don't think so. Alright. So degradation kinematics. Oh, these are technically the dummy results they have tried to give us, like the degradation rate constant for from zero order kinematic cola models, table one, and model performance for a couple of models. Alright. Predicted versus actual plot from XGBoost. So feature importance analysis discussion. I don't think the cost benefit at democratization is needed, although conclusion and reference placeholder. There are a couple of ones. So research. Okay, let's check out some links. So this was the thing I was giving. So they have given us a PDF. So set no. Alright, the PDF is loading. And Primera Engineering abstract list. Students handbook and stuff. I don't think these are needed. Let's say this was the prompt I was giving him. So never mind. No. I don't think these are usable for user purpose because these are generic models. They have tried to figure this out from the image to text model. Alright. So this ain't so necessary. If you look over the link, then we might Arabic technology abstract acrylic acid of Diana's water. Alright. So that wasn't very great, but I will try to update you guys on the very paper we are currently building. Thank you for watching, and this is part one, but for the part two. Peace.